now that I have done all the changes to the precipitation, I can continue with my editing, and the next parameter I will edit is total cloud cover. It's very advisable to have a view macro where you have all these editable parameters in order. So for example, on my row number 2, I have total cloud cover because that's the next one in line. First thing to do, of course, when we start to edit new parameter is to verify the performance of that parameter. So for example, here on the right hand side, I have the macro I'm gonna use for verification. So I'm gonna go step by step and see how the models are performing and look for the differences. So for example here, during the nighttime, I can see that there should be some clear areas in northern Sweden. But on the other hand, this model, for example, is not suggesting same features. Also, ECMWF seems to be more cloudy than this model here, so our regional model. So I would probably emphasize this model a little bit more. But before I am able to make the decision, I would say it's very important to verify the initial moment. So I will go to the time we are now and check the observations. So for example, here I have the current satellite image. And now I can verify how the models are performing. So for example, yes, we have clear areas here. We also have the same features in ECMWF and in MEPS, so our regional model. But this regional model seems to be a little bit better, and it also has clear areas over the sea, for example. So overall it seems that all the models are maybe a little bit too cloudy, because you can see all these little spots that are clear, but appears to be cloudy in the models. The same applies to the Atlantic Ocean as well. So we can see this stripe of clear skies here, but it's not that well seen in the models. So maybe there is a little bit more cloud in the models. So I'm definitely gonna emphasize the model that has better performance now in the near future when I'm editing. So we can mix the models as we did with the precipitation editing. We can say that the closest 18 hours we will emphasize MEPS model because it had less clouds, which was closer to the reality. So in order for me to do that, I can say, so now I have 80% of MEPS total cloud cover and 20% of the current edited total cloud cover, which is at the moment ECMWF, as that was the background model I chose for the base to the editing. I'm not gonna tick on this now because I want to apply this change everywhere on the map. So just click execute. And now we can see that there were some changes. So we can see more of these clear areas over the sea, for example, and over this Atlantic Ocean, as well as north of Finland. So if I undo and redo, you can see that there are some changes. Then I'm gonna check that the transition is smooth, so there is no jump between the one that we edited now and then the later part that we haven't touched just yet. So this is the one that we edited. There is a little bit of jump in the total cloud cover in north, so maybe I should pay attention to that. We want to smooth that over, so we can do that using this data filter tool. So let's do some time modification. So let's try some averaging over time. And we have the right parameter selected, no selected points, and just do time modification. And now if we go back and see what happened, so 0.5, it looks okay, 0.6 is starting to be more cloudy, and then 0.7 is gonna be overcast. So it makes sense, now there is a little bit of a transition. In some situations, you might have too much total cloud cover, especially in cases where you, for example, just have high-level clouds. So what you can do is that you can run the script to the whole edited area and then choose your time slot from the timeline. So for example, if I choose that there is too much total cloud cover on Friday, for example, so I'm gonna choose Friday on the timeline, put my green dot there, and then write the script that looks like this. So you're taking 90% of total cloud cover into account and change the value of total cloud cover to be that. And when you run the script, it will decrease the amount of total cloud cover everywhere on the map. Just note that will also decrease the amount of total cloud cover over the areas of precipitation. There it might not make any sense, so if you want to exclude these cases, you might want to use if condition. You could write something like this, that you only make the change if total cloud cover is over 30 and precipitation intensity should be less than 0.03 millimeters per hour. In this kind of macro, it won't touch the precipitation areas and the cloud cover over that. So this is one way to work with the clouds. Another way of changing the cloud cover in the editing is to do it by hand wherever you want the change to be. So for example, let's go back to the models. And tomorrow, so on Thursday, we have this precipitation area. We also have high pressure system south of Finland, which would mean that if I take a sounding from southern Finland, I can see that it's only high-level clouds. And high-level cloud is more transparent than mid-level cloud or low-level cloud. And that's the key thing in editing. You always want to edit so that you are thinking from the perspective of an observer at the surface. If you look to the sky and you can see sun shining through, as it might be the case with the just high-level cloud, you are not thinking this as 100% cloud, because you can see the sun through and you can maybe even during the summertime feel the warmth from the sun. So in editing, you want to manipulate this. So instead of having 100% total cloud cover on Thursday, 12 UTC, as it is now in the editing, I want this to be only 50%. Because I know that based on my knowledge, that's closer to the reality. So what I'm gonna do is that I'm gonna choose Thursday and time around the noon, because I was looking at 12 UTC. And you can see that it's completely overcast, no sun here. And if I hover my mouse, you can see from the mouse that total cloud cover is 99.9%. But based on what I just explained about the high-level cloud and the coverage of that, I want to modify it. So I will choose the circle selection, paint over this part on the map. So I'm gonna write a macro like this. Here I'm decreasing the total cloud cover using a random function, so function called rand. So if the total cloud cover is over 60, it's gonna be 50 plus random 10, meaning that it's gonna be a value from 0 to 10. So the overall range of total cloud cover would be from 50 to 60. I'm also taking into account the situation where I might have some precipitation, so that there is enough cloud for that precipitation to happen, so that it makes sense. So here I'm checking that if I have some precipitation and my total cloud cover is for some reason less than 70, it's gonna be 70. And then finally I'm averaging the total cloud cover over one grid point each direction. It's exactly the same as if you were using this tool and using the settings like this. That would be the exactly same thing, but it's also possible to do with the Smart Tool language, so I find it easier in this point. So I have selected this area, I have chosen selected points, and now I'm gonna execute the Smart Tool script. And you can see the change. It's a very notable change, and it kind of draws your attention, so it's not very smooth over time. So next you would have to do some time blending for this to make the change more smooth. You can do these changes to these selected point areas also with different kind of macros. So now this macro was for total cloud cover if it's over 60, But it's also possible to do it if the total cloud cover is over 70 and you want to modify it. So for example here, if I run this script to the northern part of Finland this time, you can see that instead of having 100% everywhere, it's actually decreasing the amount because we are using the random function again. But these changes are very hard to blend to your data. So there is a better way to do this, and it's just using more of the Smart Tool language and making scripts of your own. So we know that high-level clouds are covering less than, for example, mid-level clouds, not to mention low-level clouds. So you can do more advanced version of cloud editing, and here is an example of that. You can check the details yourself from this editing macro. It's quite well explained using the comments, but the overall idea here is that we are using some constants based on the coverage of that cloud level. So we know that high-level cloud is not covering that much from the perspective of an observer, so we can use constant that is less than, for example, for mid-level clouds. And when we are adding these cloud covers together to form the total cloud cover, it's more realistic this way, because it's emphasizing low-level clouds the most and high-level clouds the least. And in this example sounding I just showed you, we only have high-level clouds. So this is not 100%, even though model thinks it is. I removed all the changes I did, and now I'm going to use more advanced version of total cloud cover editing script. So I'm not gonna choose selected points, and now I don't have to select an area from the timeline either. This script is taking into account the different layers of cloud, so high level, mid level, low level clouds. So let's see what happens if I now execute. Pay attention to this southern part of Finland. So now you see that instead of 100%, my tooltip is saying 25.2%. So it's significantly less than it was before because it was 99.9%. Is this too little? Maybe, maybe not. But we can confirm this by looking at the sounding. So if I look the sounding from these areas where I just checked it there, maybe 30% is a little bit too less than I would say. I would say it's closer to 50. But with just modifying these constant values here, you can modify the output of this total cloud cover editing. So for example, instead of having constant of 0.25, I can put here 0.35, and let's run this script again. So remember to undo your change and then execute. Now if we look at the value from our tooltip, it says 42.5, which is actually pretty good value. We even have 60 here. So now it would be more realistic in this case. Now remember to check the data, that there are no major jumps or any weird features. And when you are done checking the data, you can continue to the next parameter. Note that you can do even more advanced versions of cloud cover editing macros. It just might require a little bit of time, and please refer to this SmartMed manual where you can find all the functions you have available. But I'm happy with the result now, so I think I'm ready to continue to the next parameter, which is temperature.